Hi, welcome to this video where we're going to look at square numbers and surds by using products of primes. Now, if you haven't looked at our previous videos where we've looked at primes and prime numbers, please go back and check them out. Help make sense of what we're about to do. I've already written here for us our square numbers. Didn't include one, which of course I should, but it is our number that we don't write as a product of primes because one's not a prime number, but it is a square number. So 4 can be written as 2 by 2, 9, 3 by 3, and so on. So each of them are represented as their product of primes. And hopefully you'll start to see a bit of a pattern occurring. Now it's quite easy to see with 4 that it's 2 times 2 and 9 is 3 times 3. But let's have a look at 16. What we can do with the products of primes is show that a number's a square number or find its square root by looking at whether we can break up the product of primes into 2 equal groups. Let me explain that. So we've got 16. For 16 to be a square number, it needs to be something multiplied by the same thing. We know that it's a square where the sides are the same. We've got 2 times 2 times 2 times 2 here is equal to our 16. So we could have put 2 here, 2 there, so we're putting equal amounts, sharing them equally between those 2 sides. And what we can see is 4 times 4. 2 groups times together to give us our 16, where the 2 sides or the 2 groups are the same. Might be good to look at an example where that doesn't work. Let's look at the number 20 that we know isn't a square number. It's 2 times 2 times 5 as a product of primes. Now, if I wanted to see if we could break that product of primes into 2 groups or 2 sides being times by each other to give us our square, we'd have 2 there, we'd have 2 there, but we would only be able to put the 5 in one of the brackets. So it's not a square number. Let's have a look at 36. Well, 36 we can see here, we could have, in fact, well, let's do it up here. We could have broken it into 2 times 3 times 2 times 3. Same with 64. We could have broken that into 2 groups. Same with 81. Now, how does that help us with surds? Well, if we had 20 and we're looking at the square root of 20, if we represent it as the square root of 2 times 2 times 5, we can see here that we can get the 2 out as a common side, and so we could have brought 2 out the front to simplify it, to leave the 5 in the square root. It was the part that we couldn't break into the 2 equal sides. It's a way to help students simplify. Let's have a look at how we can use our products of primes to do other roots, such as maybe the cubed root in this instance of 64. So with the square root, we're looking for the 2 sides that were the same. With the cubed root, we'd be looking for the 3 sides. If we're thinking cube, the 3 dimensions. So we need to break up our product of primes into 3 equal groups. And if we can get those 3 equal groups, then we know we can find the cubed root of the number. So we've managed to do it. And, oh sorry, I should have a little 3 there. The cubed root is going to be 2 times 2, which is 4. Lots of uses for products of primes. Don't underestimate the power, and especially if we're really pushing students on. It's not just to help students simplify fractions, but you can see the application here for them understanding square roots, surds, and so on. I hope you've enjoyed this video. If you haven't seen those previous videos on prime numbers, please go and have a look at them. Leave a review, we really appreciate it, and it helps to get the word out there about the video. And if you haven't already done it, please do hit subscribe. Thank you.